You type a question, you hit enter, and a few seconds later, a fluent, paragraph-long answer appears, as if something on the other end actually understood you. But nothing understood anything. So what really happened in those few seconds? Let's open up the black box and watch, step by step, exactly how ChatGPT turns your words into an answer. Here is the one idea that everything rests on. A large language model does exactly one thing. It predicts the next word. You give it some text, it guesses what comes next, then it adds that guess back onto the text and predicts again and again, one little piece at a time. That's it. Everything else, the tokenizing, the vectors, the attention, is just machinery to make that single guess shockingly good. Let's follow one sentence all the way through. First stop. Tokenization. The model never actually sees letters or even words. Before anything else happens, your text is chopped into tokens, common chunks of characters. A short word like cat might be a single token. A longer one like unbelievable could be 3. Un, believe, able. The model has a fixed vocabulary of around 100,000 of these tokens, and everything you type gets mapped onto them. And this has a famous side effect. Because the model sees tokens, not letters, it can be strangely bad at letter games, like counting the RS in strawberry. It isn't looking at the letters at all. It's looking at chunks. Every token also gets a plain number, an ID. So by the end of this first step, your sentence has quietly become just a list of integers. Next, embeddings. A list of integers means nothing on its own. So each token ID is turned into a vector, a long list of numbers that works like coordinates, placing that token at a point in a vast space of meaning. And here's the beautiful part. Tokens with similar meanings end up near each other. Cat and kitten sit close together. Cat and democracy sit far apart. Even directions in that space carry meaning. The classic example. Take the vector for king, subtract man, add woman, and you land almost exactly on queen. The model was never taught that. It absorbed it from reading. So your sentence is no longer a list of integers. It's a set of rich points in meaning space. Now the crucial step, attention. Take the sentence. The animal didn't cross the street because it was too tired. What does it refer to? The animal or the street? You know instantly. The model works it out using attention. Every token gets to look at every other token in the sentence and score how relevant each one is for understanding itself. For the word it, attention puts a heavy weight on animal and almost none on street, so the meaning of animal flows into it. Do this for every token at once, and each word's representation gets enriched with the exact context around it. This one mechanism, attention, is what made modern language models possible. And why was attention such a leap? Before it, models read a sentence one word at a time, left to right. And by the end of a long sentence, the start had basically faded from memory. Attention throws that out. Every word can look at every other word, all at once, in parallel. Nothing fades and nothing waits its turn. That single change is what finally let language models scale up. Stacking it up, the transformer. One round of attention isn't enough. A transformer stacks it. Attention, then a small neural network, then attention again, dozens of times. Each layer refines the picture a little more. Early layers catch grammar and simple links. Deeper layers pick up tone, intent, and meaning. The big models do this through 50, 80, even 100 layers. After the final layer, the model takes the last position in your text and produces a score for every single token in its vocabulary. 100,000 numbers, each saying, roughly, how good would this token be as the next word? After all that machinery, we are finally ready to pick one. You might be wondering where all of this knowledge actually lives. The answer is the weights. Every layer is really just a giant grid of numbers. And those numbers are the model. GPT-3 had 175 billion of them. They get tuned during training and then frozen. So when people say a model is bigger, this is mostly what they mean. More weights and more room to soak up patterns. Choosing the word. Those 100,000 raw scores get passed through a function called softmax, which squashes them into clean probabilities that add up to 1. Maybe Matt gets 50%, Rug gets 12, Floor gets 8, and there's a long tail of unlikely options. Now the model just has to choose one. How it chooses is controlled by a dial called temperature. Turn it low, and the model almost always grabs the top option, safe and predictable. Turn it high, and it takes more chances, creative, sometimes a little weird. It picks a token, sticks it on the end of your sentence, and then runs this entire process again to choose the next one. Word by word, that loop writes the whole answer. Let's actually watch the loop run. It predicts cat, sticks it on, and feeds the whole thing back in. Now it predicts sat, adds it, feeds it back. On. The mat. Each new word becomes part of the input for the very next guess. The model is literally writing one word, rereading everything, and writing the next, many times, a second, until your answer is complete. That repetition is the entire trick. So why does it feel like magic? Nothing we just walk through knows facts, or reasons, or understands. It is next word prediction. The twist is scale. Train a big enough network on a huge slice of the internet. Books, code, conversations, and in order to predict the next word well, it is forced to soak up grammar, facts, writing styles, and even fragments of reasoning. And beyond a certain size, brand new abilities simply appear. Translation, arithmetic, writing working code, things nobody explicitly programmed. Researchers call these emergent abilities, and thereby, a humble next word predictor can feel like it is thinking. It isn't, the way you are, but the result is close enough to be genuinely, wildly useful. A few things that surprise people. There are really two separate phases here, and mixing them up causes endless confusion. Training happens once. Months of computation on thousands of chips, costing a fortune, slowly tuning those billions of weights. After that, the weights are frozen. Then every chat you have is the second phase, called inference. The frozen model just running its predictions. So no, by default, it is not learning from your conversations. The knowledge was baked in long before you ever typed a word. And one last piece. A raw next word predictor, fresh off the internet, would just ramble or autocomplete your sentence. It wouldn't actually answer you. A second training stage, using human feedback, taught it to follow instructions and be genuinely helpful. That step is the real difference between a giant text predictor and the assistant you actually talk to. And this one mental model also explains the quirks, hallucinations. That's the model confidently predicting plausible sounding words when it has nothing solid to stand on. Fluent, but wrong. The context window? That's simply how much text it can look at while making each prediction. Once you see it as next word prediction at scale, both the magic and the mistakes finally make sense. So the next time a paragraph appears the instant you hit enter, you'll know the truth behind it. Tokens, vectors, attention, and one very good guess. Repeated, word by word. Subscribe for more such intuitive videos.